YouTube channel. In this video lecture, I'm going to answer all questions from Keith Williams' Airborne Weather Radar chapter. So far, I have solved first 10 questions and I've already uploaded to my YouTube channel. Now, in this video lecture, I'm going to solve the next 10 questions, question 11 to question 20, and upload it to my YouTube channel. So, if you have not watched the first lecture, do watch that and then start with this lecture. Question number 11, simple. The pencil beam of an airborne weather radar is used in preference to mapping mode for determination of ground features. So remember, always, I have explained this in my previous lecture also. For the first 70 nautical miles, you are going to use a fan shaped beam, also known as cosecant beam. For the next 70 nautical miles, you are going to use pencil shaped conical beam for mapping purposes, for mapping and weather purposes. So this pencil shaped beam will be used from 70 nautical miles to 150 nautical miles. Okay. So pay attention here. Option A says beyond 100 nautical miles because insufficient antenna tilt is available with mapping mode. Beyond 150 miles because wide beams give better definition when approaching coastlines. Beyond 50 to 60 miles because more power can be concentrated in the narrower beam, right? So option delta is the right answer. Beyond 50 to 60 nautical miles, you're going to use pencil shaped beam, okay, and within 70 miles, you're going to use fan shaped beam. So let's say if this is your aircraft, okay, this is your aircraft here. It will produce a fan shaped beam like this for the first 70 nautical miles, and for the next 70 nautical miles approximately, it is going to send a radar beam in the direction of a thin conical pencil shaped beam, like this for the next 70 to 150 miles. Now the advantage of this is that why do we not use a fan shaped beam for larger distances? First reason being poor resolution of target, okay, poor reception of target. When you use this large size fan shaped beam, what will happen? You will cover a larger area, and as a result, the energy will be distributed over a large area. But when you use this thin pencil shaped conical beam, the concentration of energy is limited or restricted to a particular small area itself. Okay, so that's why concentration of energy is another reason. Okay, so because of these three reasons, we use a conical pencil beam at larger distances, namely beyond 60 to 70 nautical miles. A frequency of airborne weather radar is, remember, 9.375 gigahertz or in the super high frequency band, and the wavelength is centimeter. So correct answer is option A. 9.375 gigahertz is nothing but 9375 megahertz. Okay, so this is wrong. Kilohertz is wrong. 93.75 megahertz is wrong. So option A is the correct answer. 13. A weather radar set to 100 nautical mile scale. Very important question. Shows a squall line. Squall is nothing but it's like a thunderstorm cloud at 50 nautical miles. By changing the scale to 50 nautical miles now, the return on the radar screen should what? So previously, case 1, we have a scale at 100 nautical miles. So I'll draw a diagram. Let's say this is your situation number 1. This is the reference line 0. You have 50 nautical mile scale and 100 nautical mile scale, like this. 50, 100. This is 100. This is a range of 100 miles. This is a range of 50 miles. Now, according to the question, there is a squall line at a range of 50 miles from you. That means here, somewhere here, there is a squall line at 50 miles. Now, in situation 2, you have changed the scale of the radar screen. Okay, you have changed the scale from 100 to 50. You have changed the scale from 100 to 50. That means what will happen? Magnification will happen. Magnification will happen. Now you will be able to see a particular area at a large scale, at a magnified, you will get a magnified image of a particular area. So now previously it was 100 nautical miles. Now it is 50 nautical miles. 50 here, 50 here. Okay, so with this, when you change the scale, the area will get magnified. Okay, and this squall cloud, which was at 50 nautical mile, now it will be represented somewhere here. Okay, so what happens? What has happened with this transition? You get to see two things. The cloud, the squall cloud will go to the top of the screen. Will go to the top of the screen. Okay, here it was in the middle of the screen. Here it is to the top. And second, magnification of area will happen. Magnification of area will happen. So correct option here will be increase in area and appear near the bottom of the screen. Wrong. Increase in area and move to the top of the screen. Yes. So option B is the correct option. Question 14. In weather radar, the use of Cossack beam in mapping mode enables us to do what? So this Cossack beam in mapping mode or fan-shaped beam, also known as fan-shaped beam, it enables better reception of echoes. That is wrong. A greater radar range to be achieved. Wrong, because with Cossack beam or fan shape, you can go up to 70 nautical miles. Beyond that, you are going to use pencil shape conical beam. Higher definition echoes to be produced, giving a clearer picture. This is another disadvantage I told you before. If you use Cossack beam or fan shaped beams, you're not going to get a good definition or good radar resolution. That is possible with pencil shaped conical beams, but not fan shaped Cossack beams. So Charlie is also wrong. Delta is the right option. With the help of fan-shaped beam, you are going to scan a large ground surface, producing echoes whose signals are practically independent of distance. 15. In an airborne weather radar, the main factors which determine whether a cloud will be detected are very important. So it depends on the size of water droplet and your wavelength, signal wavelength. Normally, we use 3 centimeter wavelength in case of airborne weather radar because this particular 3 centimeter wavelength will enable reflection from a large water droplet. Okay, if you use a wavelength which is less than 3 centimeter, okay, let's say I'll take a cloud, this cloud. I'll take 3 clouds, okay. Explain 3 different scenarios. In first scenario, which is normally we use 3 centimeter wavelength, right? And there are different water droplets in this cloud whose sizes are also equal to 3 centimeter, somewhere around 3 centimeter. So in that case, the radar beam which is going to move in this direction will get reflected back. Okay, if the size of the water droplet is equal to the wavelength of the signal. Now in second case, let's say the size of the water droplets are smaller than the wavelength of the signal. Now the wavelength of the signal is same 3 centimeter. Let's take the size of the water droplet to be 1 centimeter. Okay, so if the size of the water droplet is less than the wavelength of the signal, this radio signal will penetrate this cloud layer and go beyond it. Okay, there won't be reflection because the size of the water droplet is less than the size of the wavelength signal. So there won't be reflection. The radio wave will go beyond it. It will go through it. In the third case, let's take the size of the water droplet to be anything more than a little bit more than 3 centimeter. So it can be 3.54 centimeter. So even in that case, we will definitely get, let's take 4 centimeter. So big cloud water droplets. Even in that case, you will get a proper reflection, some reflections away and some reflections back at the receive. So therefore, the very important point, airborne weather radar, the main factors which determine whether a cloud will be detected are size of water drops and wavelength of frequency used, range from cloud wrong, diameter of the scanner wrong, rotation of the scanner wrong. So option A, size of the size of the water and wavelength used. 16. In airborne weather radar, the main factors which determine whether a cloud will be detected are again wavelength and frequency used, wavelength of the signal. Similar question next. 17. In order to ascertain whether a cloud return on airborne weather radar is at or above the height of aircraft, the tilt control should be set to what? Assume a beam width of 5 degree. So let's say this is your aircraft, okay? Here is your aircraft and the beam width is 5 degrees. The beam width is 5 degrees. So this is the horizontal line. Beam width is 5 degree, that means 2.5 degree up, 2.5 degree down. Now in order to detect the top of the cloud, okay, in order to detect whether a cloud is above the aircraft or below it, in order to detect whether it is above aircraft, you will have to deflect this radar beam. You will have to deflect this radar beam upward. Okay, deflect this radar beam upward. That means I'm going to draw a second picture. We have this horizontal line and this radar beam will be deflected upward. So what will happen is this this line 2.5 degree which was below the horizontal will now coincide with this horizontal. Okay, so 2.5 degree up and this 2.5. So this 2.5 degree line which was below the horizontal will now come above the horizontal in line with it, somewhat in line with it, and this part of the beam width will go again upward, another 2.5 degree upward. So the answer will be, if you want to detect whether a cloud is above your height, above your flight level, you will have to deflect this radar beam 2.5 degree, 2.5 degree upwards, 2.5 degree upwards plus 2.5 degree. So correct option here is option A, 2.5 degree up. Next, question number 18. When switching on the weather radar, after startup, a single very bright line appears on the screen. What is the significance of that line? So if you have seen on your airborne weather radar, there will be a single bright line, yellow color, red color sometimes. And if you see that line, what is the significance or meaning of that? That means transmitter is faulty, scanner is not rotating, scanning of the cathode ray tube is faulty, receiver is faulty. So the correct option here is option delta. receiver is faulty. Which of the following list phenomena that can be detected by weather radar? So weather radar cannot detect clear air turbulence, right? It cannot detect wake turbulence. Okay, so correct option here will be, let's find out. Dry hail, clear air turbulence, snow, clear air turbulence, clear air turbulence and turbulence in cloud with precipitation, snow and turbulence in cloud with precipitation. So here the correct option will be option alpha. Dry hail and clear air turbulence will not be detected. So in your Oxford textbook, there is a list given. Okay, the order is given. So beginning from wet hail to snow, okay, to dry snow. So there is a list given. So beginning from wet hail to dry snow, the reflectivity decreases. So wet hail, the reflectivity is maximum, and dry snow, the reflectivity will be minimum. So option alpha is the right answer. The gain control knob of an airborne weather radar adjusts what? So remember, so what is this gain control knob? So let's say you have a receiver on your airborne weather radar. There is a receiver. Now, if the gain control knob of this receiver is high, okay, that means it will receive returns which are important and returns which are also unimportant. That means the receiving capacity or receiving efficiency of this receiver will increase. It will receive all kind of returns, important ones, unimportant ones, returns coming from raindrops, returns coming from something else, from water droplets which are very small in size. Even from them it will receive returns. So unimportant ones I am writing here. Okay, that means the efficiency of this receiver has increased. Okay, so when you increase the gain of this receiver to set it to very high gain, so it will receive inputs or returns from important targets as well as targets which are not very important or useful or relevant. But when you set the gain control of a receiver to a lower setting, so it will receive returns only from targets, returns are strong and capable. So that means it will not receive returns, or it will eliminate returns which are weak or not very effective. Okay, so this is how the gain control knob functions. You can, with this gain control, you can adjust the receiver efficiency, receiver capability of your receiver. So the power level of the transmitted energy is made dependent on the selected range. The brightness is controlled, automatic gain control is activated, the receiver sensitivity in order to achieve optimum target acquisition. So option delta is the right option. Okay, so the sensitivity of your receiver is increased. Okay, if you increase the gain control, your receiver becomes very, very sensitive. Okay, it will receive returns from important targets, unimportant ones. If you decrease the sensitivity, if you decrease the gain control, sensitivity decreases. So it will only receive returns from important, strong targets. So this concludes our lecture. I will solve the next 10 questions in the next video lecture. I hope you have understood the 10 explanations I have given and answered the questions. If you have any doubts or any comments, let me know in the comment box. Subscribe to this channel and share this video with your friends. Don't forget to hit the like button. All the best.